Welcome to SSI Meetup. Today we will be talking with Orie Steele. He's one of the founders of Transmute, and he will be telling us more about how the element DID method works, how this is related to Sidetree, Ethereum, and IPFS. And I will really look forward to this because, like, just a couple of weeks ago, we spoke to Daniel Buckner from Div and Microsoft, and he told us about the Sidetree IAM method, and today we will learn about a similar version for Ethereum. Let us quickly review in slide number 2 what SSI Meetup is about for those that didn't have the opportunity to learn about it yet. Basically, what we try to do at SSI Meetup is to empower global SSI communities that are open to everyone, which means companies, individuals, anyone who's interested in learning about this can use this material, because all this material is being published with the Creative Commons by share alike license, which basically means that you can reuse this material anytime in whatever format you want. The only thing you have to do is to give credit back to the person who created the content, which today is Orie Steele from Transmute, and please also give credit back to SSI Meetup. And we will publish, as always, at the end of the session, the video and the Google Slides, which you will be able to download, and also a SlideShare presentation that you can reuse also if you want to. If you have any questions, you can bring up your questions during the presentation using the question tool. And then depending on the context, we might bring up that question at the end, or just real time as you're asking the question, so that we can share them with Orie. Orie, thank you so much for joining us today. And I think we all look very much forward to learn about what Transmute is doing here with the element DID method.
Awesome, thanks, Alex. All right, let's get started. There's this abstract slide. Basically, I'm Orie Steele. My background's in cybersecurity. I studied social network malware and botnets between 2007 and 2012. That was my first sort of introduction to identity, and especially social network identity, and the challenges around secure identity management and what can go wrong when you trust centralized providers to manage those interactions. So that was sort of my first introduction to cybersecurity, and also to Bitcoin and what people were using cryptocurrencies for back then. But in this talk, we're going to focus on the element DID method, which is an implementation of the Sidetree Protocol, which is an open blockchain agnostic protocol developed by members of the DIF and sponsored, by Microsoft. And as Alex mentioned, Daniel's already talked about ION, so there's going to be some Sidetree review that'll be kind of an overlap, but we're also going to talk about things that we've done that are different in element, including things such as wallets and signing and revocation, and how decentralization and centralization play as themes when we think about concrete implementations of DID methods. So this is the background. Motivation is there's these existing decentralized identity methods, BTCR, ETHR, and I'm not an expert on either of them. And although we have used ETHR for some time, and I found it to be generally pretty awesome, and I love the team and their work on it. The main challenge that we've seen with it is the per operation cost, and batching and throughput aren't sort of integrated in the same way that they are in Sidetree. But we've learned a lot from those methods, and I think the main sort of question that comes up when you work with them is, we have a lot of code duplication here. Is there any way that we could have more code reuse or protocol reuse? And I think the Sidetree protocol sort of vision is to support that environment. For Bitcoin and Ethereum, let us both reuse a significant amount of decentralized identity code and keep the ledger interface small. And obviously, like, higher throughput, lower costs are required for certain industries that have higher numbers of transactions, really frequently changing data, sensor data, that kind of thing. Right, so for those who don't know anything about Sidetree, like I said, it's a ledger agnostic protocol for anchoring batches of signed JSON patch operations. So really what that means is that it's kind of a conflict-free replicated data type, which is a decentralized distributed design pattern, which basically allows us to get public key infrastructure that's distributed and decentralized. And that's important as a building block for identity applications, things like SSL certs that secure your web browser traffic. Those are all managed by normal PKI, and Sidetree is a protocol for building decentralized PKI on top of blockchains. And the main sort of innovation I would say in it is the batching support for higher throughput. But as you'll see in our demo later, if you're a paranoid user, you can still anchor yourself with Sidetree, and we're going to show that. The thing to keep in mind about it is the implementation's open source Apache 2. It's supported by the Linux Foundation. Code bases for Element and IAM both live within the diff. And although Element doesn't share direct code base with the Bitcoin implementation today, at some point in the future, we'd love to be able to do that. Right, so Element, as a concrete implementation of Sidetree, has some design patterns that are a little bit different than ION. First, we took a sort of DApp-first light node approach. So we started from the perspective of you're a user, you only care about yourself, and you want to anchor your identity. And that kind of means that you don't really care about batching by default. So we're sort of starting in the world of BTCR, ETHR. And we wanted to support that use case first before we added batching and sort of delegation and trust in a server model. Obviously, the Sidetree protocol is sort of originally designed as a server client-server architecture, and so we support that as well. But we want to work from the perspective of user-driven development. So we needed to build a client application immediately to be able to get feedback on how are things working, and we're going to show that client application in a little bit. Another thing to note about Element is it's organized a little bit differently than ION and Sidetree repos. So we use Lerna, which is a mono repo JavaScript framework, so you can keep all your JavaScript packages in one repository, and that means that you can implement a UI feature, update your library, and update your API all in one pull request, and have your continuous integration tests pass, which helps speed the development. Our implementation's a little bit more functional, although it may become more object-oriented, especially as we integrate more with the TypeScript code base. And we do have a live testnet progressive web application demo, which I'm going to show in a bit. All right. So in order to have an identity, you need to have some keys. So the public-private key pair is sort of the it's the thing that you need to create a decentralized identity, which means you need to have some place that you're going to store those keys. So we have built a simple JavaScript JSON encrypted wallet architecture that works for web application demos and also will work on your machine. Obviously, like keeping private keys in a web browser, even in encrypted at rest form, is pretty much not a good idea. But it's really helpful for demoing purposes. In the future, we'd love to support native mobile applications, trusted execution environments, Intel SGX, server-side implementations, secure enclave. But it's nice not to have to deal with all of that stuff as we do our initial development. The next sort of brief thing I'll mention is that the credential formats for signatures that come from keys that are stored in your wallet, there's JWS and JSON LD. I'm just going to make a brief pitch for the JSON and LD signature format. JSON linked data is a technology that evolved out of the semantic web, and it does a really great job of expressing complex relationships between things. And being able to sign a graph or sign a complex relationship is really powerful. And in terms of API integrations, and especially for the future of decentralized credentials, I think JSON LD has a much better data structure format for representing richer verifiable credentials. And so that's the technology that we use. So the final note on wallets is the wallet file itself. You don't have to keep all your keys in one wallet, and you can also split up the wallet decryption key with things like Shamir secret sharing, social recovery. And so, in a real life scenario, you pretty much would want to do that for your recovery keys, which are keys of last resort. Cool. So Daniel probably covered this when he talked about ION, but we're just going to briefly go over it. This is the way that anchoring works in the Sidetree protocol. So you have an operation like create, update, recover, or delete. The R is recover, not read in this case. And so that's a JSON patch operation effectively. And you sign that operation with a key that you're holding in your wallet. And then you submit that operation into a batch. And that batch can contain, 10,000 operations or whatever the batch file size is for the protocol at that point. And that batch file is then connected to an anchor file, which has a Merkle root, so you can show that your operation was included in a given batch. And the anchor file also connects back to the batch file so that nodes can download the batch file when they have an anchor file. And you get the anchor file from the ledger transaction. So nodes that are anchoring Sidetree transactions are really just anchoring this single IPFS hash to a ledger. And that IPFS hash is for an anchor file. And the signing of the transaction that does the anchor file sort of anchoring, that is pretty much the only piece of Sidetree that is specific to a given blockchain. Everything else has nothing to do with the ledger really. So there's this very simple ledger interaction, and that's what now allows Sidetree as a protocol to be valuable and sort of ledger agnostic. So we have a Bitcoin anchor, we have an Ethereum anchoring implementation, and obviously ION anchors to Bitcoin. And one other thing I should mention on this slide is the signed operations are signed with a wallet key. The signed ledger transaction is signed by the node that's performing the anchoring operation. And those keys don't have to be the same, and 99% of the time they won't be and shouldn't be. You should not reuse keys. So in order to get back your decentralized identity document, which represents the keys and service endpoints for your identity, you kind of have to do a reverse anchoring. So you start at the ledger, you get the transactions, you get the anchor file hashes from that, you get the anchor files from the hashes, you get batch files from the batch file hashes and the anchor file, and finally you get to all the operations. And the operations that are specific to your DID get sort of replayed in a stream, and that's how you build up your DID document. So some things to think about here in terms of the resolution process is thinking about data poisoning, spam, and errors. Now, how do you trust nodes to handle bad data? And the thing to keep in mind about the Sidetree protocol is it's very open, and so anyone can write to it, which means that nodes have to be really efficient in processing data that was written that's incorrect. It could be an error, it could be malicious attacks, but because there's no real right side protection there, you need to be able to very quickly look at a given transaction, anchor file, a batch file, and decide not to spend a bunch of time on it if it's bad. And the first way that we do that is with the sort of indexing on the anchor file as a way of protecting you from having to go download batch files or operations that are going to be bad, that are provably bad from the anchor file. And so then the final question, I guess, is why would you even resolve a DID? Why do you need to do that? And the answer is basically, if you're trying to figure out whether a signature is valid for a given identity, let's say I want to show whether my thermometer has reported the temperature correctly, and I'm looking at a given signed temperature reading, and it has a key reference in it that is to some key that's stored in some DID document. I have to go resolve that key to verify that signature, and that process tells me whether that signature, that claim is still a valid claim. In addition, you might also you want to send a message to someone, you know their DID, but you don't know how to send them a message. If you resolve their DID document, you can look in the service endpoints and maybe find a service that you can use to contact them. And interacting with those service endpoints is kind of the future of SSI. Like, these are things like identity hubs, stores, agents, things like that you probably have heard from the community, and they're the main sort of source of interaction for interacting with a given DID sort of principle, like the person or device behind a decentralized identity. Cool. So in our architecture here, in the Sidetree architecture generally, the server is handling the batch file creation and anchoring, and the client is just creating these operations and signing them. In the case of the DApp, all of the stuff happens on the client, but this is the sort of traditional way that Sidetree handles these things. Cool, so with that, I think we're gonna dive into a demo. So hopefully we don't lose everybody as I attempt to escape this presentation. All right, so this demo is of Element. I should also mention Element's under active development, and it looks like it may be down, which would be particularly sad. This is hosted on Firebase. This is centralized cloud functions and static web application hosting, and so occasionally it goes down. But what we're gonna try and do today is we're gonna start by creating a wallet to have some keys, and then we're gonna try and create an identity ourselves. And then if the application plays nice, we're gonna go show that you could resolve that identity by going to a server. So the first thing is we need to go create a wallet. So we have this wallet creation process here, and this password just is used to encrypt the private keys that are stored in the wallet. So I'll show you what that looks like in a second. This is obviously just for demonstration purposes. You wouldn't never really want to do this for any kind of real production use case. So when we import the wallet, it's locked. It's encrypted by default when it's saved to your machine. So we're gonna unlock it, and we can see that we have a key that's stored inside it, and that key is the kind of key that you can use to sign Bitcoin and Ethereum transactions. So with that, I'm now gonna go over to the My DID section, which it can tell me that my DID will be this. And what's kind of cool about this is that because of the way that Sidetree identities are created, if you know the keys that you're gonna include in your identity document, and you know the service endpoints that you're gonna be including in your identity document, you can calculate what your identity would be without even anchoring it to the ledger. So that's what's happening here, but we wanna go make sure that this is actually gonna be anchored. So we have to wait a second, and MetaMask is gonna pop up and ask me to sign this transaction. You can see that it's pretty cheap to do. I'm gonna go ahead and do it. And we're gonna have to wait for a Ropsten transaction confirmation. And like I said, this is the sort of DApp first experience. If you were creating an identity using a server, the server would be responsible for performing this anchoring, and probably would batch your operation with others. And you wouldn't actually have to pay anything for that, because the batch would be paid for by whoever is hosting that server. Which, if it's you, it's just like what we're doing now, except that you had to run a server to do it, potentially, if you're in the IAM implementation. But if it's not you and you're trusting, some hosted IAM nodes to anchor and create your identities, or hosted Element nodes to anchor and create your identities, then you submit your signed transaction to them and they anchor it. So you can see, it's taken a little while, but our Ethereum transaction confirmed, and we now have this, identity document here. And there's some UI here for adding and removing keys to show some of the different DID operations that are supported currently in the demo. The main thing, here that we want to do is, and I'm scared that our Firebase servers are going to be down, but we're going to check. We're going to copy this identity here, and we're going to go see if we can resolve it from the full node service, which is basically just a cloud function that's not running on my local machine. So I'm going to go over to the DID resolver, plug this in here. I actually have to press the button. So what's happening here is that we're asking our cloud functions, hey, do you know this decentralized identity? Can you give me the document? And it's actually going to the ledger, getting the transactions and following that whole resolve process. And you can see that it's able to resolve the same identity that we had, when we're looking at it in our local browser. And this sort of shows you that this data isn't just living locally, it's available to any nodes that can talk to the Ethereum and IPFS services. So this is basically all that I had planned to show. You can see that there's public keys listed here. There's one other thing. We built a block explorer for Element to be able to sort of understand what's going on with these transactions in Sidetree. And everything I'm about to show you in this block explorer is pretty much applicable to ION or any Sidetree implementation. So the first thing you'll see is there's these transactions, like this is the most recent one that we just created. And inside of the transaction, there's this anchor file, hash, and the block that the transaction is included in, transaction hash. If we want to go look at the actual Sidetree transaction, we can go and do that. And it's going to pull up these different sections here. And so the first section is this section that we were just looking at, the anchor, sort of the Ethereum transaction or Sidetree transaction view, which just has a transaction number, a block time hash, and an anchor file hash. If you go get the anchor file, that has these fields in it. So it has a pointer to the batch file, has the Merkle root, and it has this index that we use for performance, which is subject to change. So again, everything here may change. So once you have an anchor file, you want to go look at a batch file. Here's the batch file, and inside of the batch file are the different operations. So here's our create operation. This is what we just did to create our identity. So we created a DID document that just had some keys in it, a primary and a recovery key. And if this batch were anchored by a full node, then there might be other operations in here, but since we just paid to anchor ourselves, there's just one. So this sort of model, with this sort of single identity update operation per ledger transaction is similar in a lot of ways to the original Uport implementations with Ethereum and IPFS integration. And it's still sort of similar in cost to the way that ETHR operates today. It just has these extra IPFS bits, which are mostly to support the identity operations that are in a blockchain agnostic way. So there's a very thin blockchain layer in all of this, and most of it is just sort of IPFS data structures and signed JSON patch operations. So that's the main, I guess the main thing to show. We have one additional view here, which is for this this given identity that we just created. Yeah, we can see all of the operations that are specific to it. It should just be one, but as you would update your identity document, adding or removing keys or performing recovery operations, those operations will show up here, and you can use this block explorer to kind of debug what's happening to your identity, figure out what's going on. So that's basically it. I think I can show. I mean, everything that I'm showing here in terms of the block explorer is running against the server. So we're relying on that server to handle all of this, but all of these same things exist in a local dApp version that you can run in your browser. It's a lot to ask a browser to, store all these transactions and operations, but we use PouchDB, which is the same technology that powers CouchDB, which is what NPM is hosted in. And so it's a very scalable, portable JSON database with syncing capabilities and that kind of thing. So we've done our best to try and support a development environment where you can run a full Sidetree, or a light Sidetree node in your browser and resolve your identity document or create new operations without needing to even use a server at all. But we also have a server implementation that's very similar to the way that IAM works. And I should mention that this demo, obviously, it's still under development. It's hosted in the diff. If you want to give it a shot, you can go check it out, elementdid.com. And it's hosted on GitHub. So if you have any problems or you want help, please open an issue, and I'll be happy to help debug what's going on. Hopefully it just works and you just want to tell us how great it is. But if you do have any trouble, I will personally help you because we're looking for feedback on this. We want to make sure it works for everybody. So thanks.
Thank you, Orie. Actually, this just, like maybe a very detailed comment already from Luca. Luca is saying he tried to install to instantiate the element solution, and he found a problem, and that you helped him, which was really great, and that he saw now the instructions for the installation have changed from a few days ago, and there's still some scripts missing. And he's asking, when do you expect to have a release for smooth implementation and installation?
Yeah, that's a great feedback. Yeah, so in order to get it up and running locally right now, you sort of need to know a little bit about Ganache and IPFS, and you have to run these scripts. And so we have just pushed some updates that try and sort of improve that process. And I should mention that the CI server uses those scripts, and we have CI tests that require things to be passing, and Travis runs in a Linux environment. So if the tests are passing in the CI server and you pull down the patch at that branch or the commit at whatever version passed in CI, you should be able to follow the Travis YAML setups scripts that are running, and it should work because Travis has access to Git. That's it. So it doesn't have there's no secrets or anything like that Travis would have that you wouldn't have. But this most recent update that I think you're referring to, we've tried to create some scripts to handle spinning up IPFS and Ethereum in a local development environment faster. And so we think that that's going to help, but I think the other solution to that may be to just Dockerize the entire thing and give people an opportunity to just run a single Docker container or Docker Compose that does everything. And that's also on our roadmap.
Great. David is asking, how many DIDs can a person create for themselves on this platform?
It's unlimited. So there's nothing. So this is a really great question. So decentralized identities there's this identifier piece, this piece here. And then inside of that, there could be many keys that you would want to use to basically authenticate, or be verified as this identity, as someone controlling one of the keys registered to this identity. You want to be very careful about not reusing a key across multiple identities, because then there's correlation between that, identity. So like DID1 and DID2 both use key A. I think it's the same person, in control of them. So one of the things that's very popular in the community is to create pairwise unique identifiers for services. I think Uport does this now. Yolocom has support for it. Element also has support for this mnemonic system, using the HD BIP39 mnemonics. You can generate a new key pair from a single secret, and you can generate a unique DID just by incrementing a number, and then use that identity just for a single purpose. There's nothing in the protocol that prevents you from doing that. You're certainly welcome to create a new identity every time you want to do anything. You may have trouble because each new identity starts with reputation 0. So if you're in the future, if you're trying to post on Hacker News and you need some credit or karma or reputation to be able to post, if you create a new identity to do that, you might not have that reputation, but you certainly will have.
Great. Thank you, Orie. Just a couple of questions, just trying to get a little bit of more background. Could you tell us a little bit about why you started Element and how it happened? Because I remember you really had this idea when you participated in a hackathon, right? And that's where that was a little bit the starting point for this.
Yeah. So I should mention that as the co-founder and CTO at Transmute, we've worked in the sort of Ethereum blockchain ecosystem since around 2016, when we first participated in a hackathon. And that purpose of the hackathon was, the theme was mobility, which they were thinking more vehicles. It was sponsored by Daimler. But we pitched a identity application for Syrian refugees. And the idea was people who have no form of documentation, no wallet, no passport, you start with nothing as a human. And we want to give you a system that provides the strongest identity guarantees and lets you sort of ratchet up your reputation as you are able to get credentials and manage a wallet and these kinds of things. And there's a whole bunch of challenges with that. But that was our first sort of foray into building decentralized identity applications. We won that hackathon, and then we went and learned about Uport and how they were working on a very similar architecture already. And we've been in this space ever since. I should say that at Transmute we're really excited about two aspects of decentralized identity. The first is the ability to really protect users and their private information, especially in a world with GDPR and increasing privacy and surveillance. We want to make sure that users have tools that are usable cryptography to help protect privacy. We also think that this is a technology that can help companies be safer, and so we want to see more mainstream corporate adoption of decentralized identity, because corporations are going to want to do that, as it allows them to shift the burden of responsibility to the consumer for certain things, and to trust and have higher degree of confidence in their interactions with their customers and partners by leveraging stronger cryptography. So at Transmute, we have Element, which we build in collaboration with diff members, and it's hosted within the diff. But we also have Transmute ID, which uses Element both for identities and for verifiable credentials, which is something that I'm not going to talk about in this presentation. But what TLDR is that DID documents are a really reusable and flexible tool, and you can do lots of stuff with them. And the other thing that we have is we also have GitHub DID within the diff, which is centralized, but it's sort of a development tool. So we have those three main pieces that we work on. I should say most of my time is spent on Transmute ID and user experience that's built on top of Transmute ID, which it uses Element internally, but the user, it looks a little bit different than this. But the original question was about the background and how we got started, and we initially were looking at decentralized identity applications to help refugees, and I still think that's a really awesome use case. I just think that there's probably better teams that are closer to the front to handle that.
Yeah, I have another question here from David. He's asking, isn't this I'm really interested in your answer. Isn't this a tool which crime syndicates will use to create synthetic identities, as it seems there's no provable link between a single real human and a DID? Yeah,
this is a really great question. So the general form of that attack, it's called like a Sybil attack. So a Sybil, it's named after a woman who had many personalities, I think. I don't know, you should go check the Wikipedia, don't listen to me. But Sybil attacks are pretty common in any network that doesn't have a strong central authority that binds one-to-one the identifier to a human principal or device. Because if there's no central authority to decide, okay, you get a new identity, then I can come and I can just keep registering new identities. So I could have hundreds of DIDs that are all me, but that no one knows that they're all me. And this is a thing that happens today in regular social networks. So you might think that you're talking to 5 people in a Facebook group, but those 5 people could all just be bots that are controlled by one guy. And if they're all telling you to buy a product or vote for somebody, that can be like really, really problematic. And so even in systems that strongly check identity and have a strong central system like Facebook, these attacks exist and they've been used, against people. And we've all been harmed by those kinds of Sybil attacks on a wide scale. They are not, the way to solve that is at the point at which you're about to interact with a given identity, you can authenticate that person. So like you can ask me to pass some biometric challenges for my unique ID, and I can use a key that is registered to my identity, and I can maybe pass your biometric challenges for this one use case. But you won't ever know whether that individual user may have other identities. But if one of those other identities comes and presents itself, so let's say I have DID1 and DID2, and then you as the central authority or as the challenging authority authenticate me in one channel, and then I try and come and authenticate in the other. If your authentication mechanism can detect that I'm a different person, then you can defend against that attack. And if it can't, then you literally can't do anything about that. So that's just the nature of any identity system that's open and that's free for new users to create identities. It runs the risk of people trying to use the system for nefarious purposes. But I should say that like being able to register public key crypto to an identifier is that's the kind of thing that needs to be available and open to everybody. And we should be thinking about the people who are going to be using that technology to maintain their privacy and security, and thinking about their rights to privacy and security before we start thinking about, okay, like who's going to use this technology for bad? Technology is a tool, can always be used for good or for evil. We need to make sure that this technology is available for people who want to do good.
Thank you. Just one thing I mentioned to you before, like in the Ethereum ecosystem, like so far, like the main identity initiatives I knew about, at least, is Uport, Ident3, and ERC 725. How do those initiatives compare to what you're doing with Element right now?
Yeah, that's a good question. So, one thing that I've always felt about decentralized identity is that it is mostly about public key cryptography and very little about blockchain specifically. And so I think that the difference between those Ethereum initiatives and Element is that Element is really mostly about Sidetree, which is mostly about blockchain agnostic, decentralized identity operations. It's a very thin Ethereum layer that performs this anchoring of anchor files to the ledger, or really anchor file hashes to the ledger. And that's it. Like, this is not really, it's really easy to build super awesome applications on Ethereum because of the excellent developer community. And I think that this is something that Ethereum has that Bitcoin doesn't have in the same kind of way. And we've worked in the Ethereum ecosystem for some time, and those other Ethereum projects, developers who've built them have spent, a lot of time and effort figuring things out, and also have improved the Ethereum developer tooling to be able to build those products significantly. And we all benefit from those Ethereum specific tooling and infrastructure pieces. The main difference between Element and those projects is that we basically try and do as little on the blockchain as possible, and they're to a large extent built mostly on the ledger. Although I should mention, like, Uport, obviously has a mobile application, a really rich client experience, and that, that stuff isn't, that's not smart contracts running, that's good developers building mobile applications. But in terms of the core identity protocols, we think that there should be a very common, very generic interface that is blockchain agnostic, that you have a single implementation point for Ethereum, Bitcoin, whatever the next blockchain is that you want to work on. You should be able to build that thin interface, and then you should be able to reuse all of this identity code that's above it. So that's a main point of distinction, I would say.
And I mean, since both Element and IAM are based on Sidetree, what is the reason for developing like another DID method on top of Sidetree for Ethereum in comparison to IAM, for example?
Yeah, so I mean, there at the time, I mean, Sidetree as a protocol is still under development. I should mention as well. So one of the things that's nice about having multiple competing implementations of protocols is that you find the edge cases, and it helps you sort of map the unknown space or figure out where you need to be more specific. So, you know, it's Sidetree as a blockchain agnostic protocol means that, you know, it should support other blockchains. And, you know, with IAM focused on Bitcoin, you know, we have a lot of experience working in the Ethereum ecosystem, and we care a lot about the sort of blockchain agnostic protocol piece. And we found that, you know, we could contribute Element as a specific implementation of Sidetree on Ethereum. But the way that will end up, you know, shaking out ultimately is that, you know, the ELEM DID method will be a set of contracts on the Ethereum mainnet and on various test nets. And the rest of that technology, you know, the core open source technology, it's very similar to DID ETHR. Like, you could change the contract address, and you could get a different DID method namespace underneath all of it. And that's a really valuable feature, especially if you have, you know, different, you know, corporate use cases that want separate isolated namespaces. If you want some sort of consortium style private Sidetree identities, you don't necessarily have to publish all of these anchor files and batch files. You can just make them available to consortium participants. So we think of Element as really a concrete decentralized identity building block, and a lot of this sort of these other, you know, there's other layers that handle presentation or specific implementation details that should be built on top of it. And Transmute ID is one of those, I should say. Like, we're using Element inside of Transmute ID to handle linkages between centralized and decentralized identities for the purposes of working with verifiable credentials and improving user privacy.
Awesome. In relation to cost, like, I mean, like you were just showing the screen before where like the cost was showing in ETH, I guess. Well, it has to be in ETH. How does it work in the sense of, do people have to get ETH, or is it just like the system, like the protocol who's funded? And just one more related question in terms of token, also, like, what is your view about using tokens in identity systems or not using them?
Those are good questions. So the first thing is, you know, in the demo that we just gave, we created an identity and we anchored it ourselves. And so we needed ETH to do that. So I have some Ropsten testnet ETH in my MetaMask account, and I spent that to be able to create this identity. So if you have Ropsten testnet ETH, you can go create your own identity right now. You just go to the website, turn MetaMask on, allow it to connect, because MetaMask has privacy features now, and you can go create your identity. So it'll cost you some small amount of testnet, Ropsten testnet ETH to do that. If you were, in the future, if you were a user of a mobile application, or of you're just a regular web user and you don't want to run a Sidetree node, then you might actually send your create operation to a server, and that server would need to have ETH to pay for you. And I should mention that Sidetree server has to talk to an Ethereum node at the end of the day. So, you know, shout out to MetaMask and Infura, because they're powering all of this demo right now. Like, in the browser, MetaMask uses Infura behind the scenes for Ethereum nodes, and we use Infura for IPFS nodes in the browser as well. So I'm not running a local Ethereum node or a local IPFS node. I could, but I'm just using Infura to do that today. And the Sidetree nodes that we use, you know, are full node also using Infura, and, you know, for the Ethereum connection and IPFS connections. So either you trust a service like Infura and trust a service operator like our cloud functions to handle all of this, or you run your own IPFS, your own Ethereum, and your own server, and you connect to them. And in that world, you need to be able to pay for your own transactions. The second question about tokens, I think there's a lot of incentive to create token velocity in the Ethereum community for various different purposes. And I understand why that incentive exists. And I think to some extent, if the token velocity is tracked to real, actual human value, I think it's great. I do worry a little bit about any on-chain operations that might be used for the purposes of correlating against off-chain, real human world activities. So as an example, if you're updating a key every time you go to buy groceries at a grocery store in your Element DID, then I can just look at your DID and see every time you've been to the grocery store, because every time you go to the grocery store, you're updating a key for some reason. So that would be like a bad design pattern just for updating a key. If the tokens are actually used for like identity claim information, then there's even more information available to the attacker to try and correlate or reduce privacy. So you should think of ledgers as public, because they are, like the ones that we use are. And the attacker is going to look at every piece of information that they have that's public, and they're going to combine that with every other piece of public information that they have, and maybe some private information that they have that you don't have. And they're going to perform those joint operations, the statistical correlation, and whatever they get at the end of that process is the erosion of your privacy as a user of that system. So you want to make sure that you're not giving extra, pieces of information to the public system that might be used for correlation later. And I think a lot of the token applications that have to do with identity end up providing excessive information to attackers that have the ability to perform widespread correlation. But that's just my personal perspective, and I mean we've benefited a lot from some of the Ethereum software tools that are developed by people working in that space.
Thank you, Orie. That's great. I really look forward, because we discussed it before, to do those other sessions, and maybe after the summer. And if you're planning any with anyone about elements and what you're doing.
Sorry, you cut out. Can you just repeat the question real quick?
Oh yeah. Any final thoughts you would like to share about the things you're doing and what you're planning for the future?
Yeah, so first of all, thank you so much for hosting us here and giving me the time to share the work that we've done on Element. We hope that this sort of user-facing demo and the time we spend on user experience in the Element and Sidetree Ethereum ecosystems help move the Sidetree protocol forward. And we're looking for contributors to the Sidetree protocol, the generic protocol itself. So if this is something that you're interested in, whether you're a Bitcoin developer or an Ethereum developer, come find us on GitHub, ask questions, dive in. We're a friendly community. The other piece of that is that Element is a building block, for identity and for us at Transmute, also for verifiable credentials. And so if you are a business and you're interested in secure decentralized identity and secure verifiable credentials and workflows, we've a product called Transmute ID, which I'm hoping we can do a session on at some point in the future, that uses Element. That's a little bit more focused on business integrations and less on pure SSI decentralized identity. And the other final thought is there's also GitHub DID, which I mentioned also in the diff, hoping to do a session on that at some point. But I think overall, the main takeaway that I want to give is that a lot of the stuff that we're doing in the Sidetree ecosystem the idea is that it should be reusable. So if you contribute to Sidetree, you might not just be contributing to the Ethereum implementation, you might be also helping the Bitcoin implementation. I think that that's the real power of the protocol, is that it's a unifying protocol. It allows developers who care about these different systems to create value for each other by working on a single protocol. So we're really excited to be contributing to Sidetree, and that's why we built Element.
That's beautiful, and yeah, I really look forward to do those 2 sessions with you. I'll ping you via email to do that. For everyone else, next week we will be talking with Daniel Duseuil and Carlos Pastor from EPSI, that's the European blockchain group. They will be talking about the European SSI framework and tell us what it is, how it works, how they want to make it work with GDPR and ADAS and other standards. So that's the next session we're planning. A couple of other cool sessions we're planning also now for late July and late August. And of course, we will be talking with Orie soon to plan more sessions, hopefully also for the late summer, early September. Just check us out on Telegram, Twitter, the newsletter. Those are the channels where we usually update everyone for new webinars coming up. And Orie, thank you so much for taking the time and sharing all this. And I think it's a great initiative to have an open protocol like Sidetree, where hopefully many different platforms will agnostically benefit and for identity. So that's really great.
Awesome. Thanks for having us.
Thank you. Bye-bye.
Bye.